Today we're looking at page 2 from exam 2 from the spring semester, and the first part is asking us to go through a series of multi-step synthetic pathways here to see what our product is going to be. So let's follow through our synthesis and see what we can come up with here. So A, we're starting out with a simple Friedel-Crafts acylation. This is one of our core reactions that we learned in this chapter. Right, we're turning an acyl group into a ketone that's bound to the benzene ring itself. So that's adding an electron withdrawing group to the ring. No rearrangements, no worries about that stuff. Now A transforms into B. A transforms into B, and it's a nitration step. Now remember, when we do the acylation, when we're doing our acylation, we add an electron withdrawing group, right? Our carbonyl group's right there is an electron withdrawing group, a deactivating group on the ring. And so we're going to add that nitro ortho to that deactivating group. Okay, cool. So A and B are done. A goes to C. So let's take a look at C here. Right, we got a zinc mercury amalgam with HCl. So that is our setup for a reduction, right? So we're just going to get rid of our ketone there, right, and turn into an alkyl group, a somewhat electron donating group. Good stuff. Okay, so there's C. C gets transformed into D, right? We're doing a bromination. All right, so we're adding that bromine group there. All right, we're good to go. There's D. Now D gets transformed into G and E, so we could either go, in either way here. Let's just go with G since that's kind of our dead end here, in the sense of, right, that's the end of the line. So we're bringing in ammonia here. Not a particularly strong base. Decent nucleophile. We got a decent leaving group at a somewhat unhindered position there, that secondary benzylic. So, truth be told, we don't specify a high temperature, so we assume it's room temperature or below. We're kind of pushing towards an SN2 here, right? My goodness, I'm sorry, guys, for some reason I can't seem to draw a decent benzene ring today. I'm not sure what it is. Hey, that one looks decent. All right. Anyway, right, we're pushing towards SN2 conditions here. We're pretty good at stabilizing a secondary benzylic carbocation there, given its position. So it's not unreasonable to say that there's an SN2 that's going to occur there. Although, if we did warm this up, we would probably get an elimination also. And so, but, we're not heavily favoring one over the other here, right? So if you put an elimination, you got some partial credit for that too, if you, kind of follow your other work there. Anyway, let's switch to red here, right? So we're going to go to E and F. Okay, so D goes into E. What do we have here, right? This is our strong base, right? So we're really pushing towards elimination here with a strong base. All right. And then, so once we eliminate, then we're going to add HBr again. So we're kind of back where we started, which, this is a problem from the book. I'm not 100% sure what the book was doing with this, or I guess maybe they were just trying to prove a point or something like that, but, Anyway, there's E and F for us. There are some minor products along the way that, we did count for some partial credit. Remember, one of the themes for organic chemistry too is, competing reactions and, what do we mean by major versus minor products. And so here's kind of what we were looking for. And let me zoom out here so you guys can kind of get the whole view of things here. Okay. Wonderful. The last part here was pretty straightforward. Just asking for some names. All right, so we got our buddy styrene here. one of the most important compounds. This is our buddy anisole, and this is benzaldehyde. Alrighty. Alright, that's page 2. I'll see you in the next video, or we'll go through page 3 then.